Hi, everybody. It's Mr. Carr again. Today we're going to be talking about 8B Day 2. Today we're going to be graphing our quadratics when they are in vertex form. So yesterday or last class we talked about standard form. Today we'll be talking about vertex form. Okay. As a reminder, since we're graphing quadratics in vertex form, this is our basic version of that. And actually, let me put that down here instead of right under there. Okay. Our vertex form looks like this: a times x minus h squared plus k. Okay, so the vertex form gets its name because you can actually find the vertex from these points. Okay, h and k are the vertex, h comma k. Okay, so that means if you look at that, that's x minus h, and that's a positive h. So it's always opposite signs. So you'll see that when we go over these examples here. Okay, what's nice about that is it's a very quick and easy way to graph. So graph this quadratic, we'll start with our vertex. Okay, because it's a -4 here, my vertex is going to switch it to a +4. -6. If I look back here, it's a positive k. Those always match up. So we have a +4, -6 is my vertex. So let's go over here and plot that. So I got +4, -6 right there. Okay. Now, just like we did yesterday, we want some more points to help with this. If I make myself a quick chart like this, so I got x and y, and I'm putting 4, -6 in the middle. That's what I want. I want my vertex in the middle of all the points. So let's try 3, 2, 5, and 6. Okay, so we get some more points off of that so we can see how this looks. All right, so if I do that, let's start with 3. So we got 3 minus 4 squared minus 6. So order of operations tells me to subtract the 3 minus 4 first. So I'll do 3 minus 4 is -1. Okay, so y equals, that'll be a -1 squared is a +1 minus 6, and then I get that as a -5. Okay, so that'll be right here. Next number I'll do is a +2 now. Okay, so let's do y equals 2 minus 4 squared minus 6. Okay, so y is equal to a -2 squared, whoops, minus 6. So that's going to give me a +4 minus 6, which is a -2. So a +2 should come out to a -2 right there. Since I put my vertex in the middle, I feel safe saying that 5 should also get to a -5. 6 will get me to a -2. Whoops. Get to a -2 as well. Okay, there's that symmetry again. The vertex and the axis of symmetry are right here in the middle. So 5, -5, 6, -2. And that's all I need there. Okay, and that's it. Again, quick summary. We find our vertex from those two numbers, 4, -6. We can create a little chart here where we put the vertex in the middle, and then we plot points here and here. Okay, let's try another example. So vertex again, +1, +3. My vertex is going to go opposite the h value, so it's going to be a -1, and then still a +3 there. So -1, 1, 2, 3 up here. All right. So if that's my vertex, I put that in the middle. So I'm going to go -1. Let's go -2, -3, 0, and then 1. So, and this time I'm going to go down because I think 0 is going to be easy to work with. So here's my function notation. Let's find f of 0. So it'll be 2 times 0 plus 1 squared plus 3. So we get 2 times that 0 plus 1 is 1. Okay, 1 squared is 1 times 2 is 2. So this will turn into 2 plus 3, giving me 5. All right, the next one I'll do is a +1. So f of 1 is going to be 2 times 1 plus 1 squared plus 3. So f of 1 is equal to 2 times, 1 plus 1 is going to give me 2 squared. Doing this properly, I'm going to do 2 to the second power, so that's 4, and then times 2 is going to give me 8 plus 3, which gives me 11. So at 1, we get 11. And then thanks to symmetry, I feel safe saying that that's going to be 5 and 11 as well. So those are the 5 points I'm going to plot. I've got 0, 5, and then 1, 11 will take me into 6, 7, 8, 9, 10. Yep, I'll go 1 off the board there. -2.5, and then -3.11. Okay, so that's plotting and graphing our vertex form. Find the vertex, pick some more points off of that. Okay, one thing I do want to highlight, here's our y-intercept again. Okay, remember x equals 0, that gives me my y-intercept. So that's a nice way to see that. I didn't get to see that in the previous problem, but if I wanted to get the y-intercept, I can go ahead and just plug in 0 for x and solve that out. All right. So application problem, we're gonna look at another type of word problem here using our vertex form now. A model rocket is launched from the roof of a building. Its flight path is modeled by h of t equals -5 times parentheses t minus 3 squared plus 55, where h is the height of the rocket above the ground in meters and t is the time after the launch in seconds. Okay, so we're going to graph this. So let's start with finding our vertex, right? So, well, okay, label the axis. So we have x-axis here is going to be time. This is going to be height. Okay, and that's in meters, and this is in seconds. Okay, so then the next thing we look at is vertex. So the vertex here, if I look at my numbers, we've got -3 and a positive 55. So that's going to go opposite the -3, but then the same as the, same as the 55. Okay, so I know after 3 seconds, we're at our vertex. So I'm going to make sure that I got 3 seconds right here in the middle, we'll say. And so that means let's go 2 and 1. We'll go 4, 5, 6, and then even we'll go 7. Okay, for height, this is 55. To help me out, let me find one of my intercepts. Let's start with the y-intercept. Okay, so remember the y-intercept is when x equals 0, so that's what I'm going to solve for. H of 0 here. So that's going to be -5 times 0 minus 3 squared plus 55. So h of 0 is going to give me -5. That'll be 0 minus 3 is a -3. Okay, so -3 squared is going to give me a positive 9. So we'll do that first. That's -3 times -3 is a positive 9 times a -5 is a -45 plus 55, giving me a positive 10. So that means I have a y-intercept of 0, 10. Okay, so I know the maximum is 55. I got starting at 0, 10. So let's go tens again. 10, 20, 30, 40, 50. Okay, so here's my first point. After 3 seconds, we're at 55. We'll go up to 60 here. So we know that's right here in the middle. Okay, so there's my vertex. And again, because of where my y-intercept is and my vertex is, the overall path is going to do this. Oh, sorry, that froze up. The overall path is going to do this. To help with my symmetry, again, this is the axis of symmetry is at 3 seconds here. So if I can use this point, I can go right here, 1, 2, 3, 1, 2, 3. 6 seconds should also have a height of 10 meters. Okay, so I know it's gonna, without plotting any more points, I'm just gonna know it's gonna do roughly, oh, hello. Let's draw that a little bit better, a little more parabola shape. There we go, something like that. Okay, so again, this is a model rocket, so we're taking the rocket, it shoots up in the air, hits that maximum height, and then it starts falling to the ground thanks to gravity. Okay, so how high is the rocket after 1 second? 1 second means t is equal to 1. So I'm going to say, what is h of 1 here for my function notation? Again, this is where it's going to be at. Roughly speaking, I don't know, I'm going to guess right around between 30 and 40. So let's see what happens. So h of 1 is equal to -5 times 1 minus 3 squared plus 55. Okay, so h of 1 is going to give me -5. 1 minus 3 is going to give me a -2 here. So again, -2 squared, we're going to do that first because it's the exponent. So it's -2 times -2 is a positive 4. Positive 4 times -5 is a -20. Plus 55 is going to give me a positive 35. Okay, so after 1 second, it is 35 meters tall. Okay, which is, yeah, that's pretty close to what I have on there. Go me. All right, was the initial height. So initial height, I've actually already found this. Initial height is the y-intercept. Okay, and that's what we did over here in the to help us plot this graph. So we have, since the y-intercept is 0, 10, the initial height, boy, I'm having trouble spelling today. Initial height is 10 meters. Okay, what is the maximum height of the rocket? So again, maximum has to do with the vertex. Okay, the maximum height is just the y value here. We don't care about the 3. We're not going to actually just put the vertex in the answer. The question is, what is the maximum height? Okay, so the maximum height is 55 meters. After how long will the rocket hit the ground? This, we don't have a good way of getting that yet. Okay, so what we're going to look at here is, we can kind of just give an estimate. Okay, if it's traveling this path on the way down, chances are it's going to hit somewhere between 6 and 7 seconds. So we're saying, when does it hit the ground? We can say between 6 and 7. Based on my sketch, I'll say 6.5 seconds. Okay, so we'll say 6.5 seconds. If I want to confirm that, let's try h of 7. If I plug in h of 7 here, either I'm at 0 or a negative number. If it's still a positive number, then I'm like, it hasn't quite reached the ground yet. Okay, so h of 7 will look like -5 times 7 minus 3 squared plus 55. So h of 7 is -5. That's 7 minus 3 is a 4. 4 squared is 16. So we're going to take -5 times 16 plus 55, which is a -50. That's a -80 plus 55, which is, yes, a negative number. This rocket is not going underground. -25. Okay, the rocket is not going to go underground over here. Okay, so what it is we are correct in assuming it's somewhere between 6 and 7 seconds. So 6.5 is pretty close. We'll call it that. All right, that's it for our graphs in vertex form. As a quick reminder, for graphing this, it's much easier to find the vertex based on our points here. It's opposite that value here. So -4 turns positive, -6 stays negative here. Okay, same thing here. +1 becomes -1, +3 stays +3. Okay, so use the vertex as our starting point. Pick some points that are above and below. So sometimes we have to plug numbers in, okay, and we find out those other values. Thanks to symmetry, we don't have to keep finding, we don't have to do 5 calculations. I feel confident that if I do these 2 calculations, we'll have the symmetry on the other side of the graph. Okay, and that's it for today. All right, take care, everybody.